complete the logic, okay, to identify whether the given number is prime or not. Okay, so we it's not good suppose if you go with what brute force approach. Okay, because every time, suppose if I wanted to say, if I say this number n, let's say if I wanted to say this 7 as prime. Okay, how I can identify, uh, if I wanted to say, okay, let's try doing it. If I wanted to say this 7 as prime number, okay, first I need to take this 7, and if I start, I should divide it by 1. Okay, 1 7 the 7, I am getting r as reminder. That's fine. And let's take 2, 2 by 7. Okay, I will take 2 3 the 6 and 1. Correct, right? So it is also not exactly divisible by. Correct, right? And if I take 3 7, okay, 3 2s are 6, 1 I am getting reminder. When it comes to 4, okay, 4 ones are 4, okay, 4 3 I am getting as reminder. Correct, don't you think so? And when it comes to 5, 5 sevens are 5 ones are 5, and I am getting 2 as a reminder. Okay, because this 7 is not getting divisible by any other number. Okay, when I divide this 7 by 6, I can write. Correct, right? 7, 6 ones are 6, and 1 I'm getting reminder. Okay, when it comes to 7, 7 ones are 7, and here. So if you observe this here, okay, so we are getting 0 as reminder only in two cases, from 1 to 7. Okay, so that's why 7 I can call it as prime. Correct. So this is what we have discussed. But if you wanted to write a code to it, okay, we can write the code. But we have one more algorithm called sieve of Aristoteles. We will be going to discuss that, because that will help you to because see, that will help you to compute, or to tell whether the given number is prime or not in a very less number of iterations. Okay, so it will just take root 7 times. Okay, so whether okay, but here we need to do 7 iteration. Root 7 is pretty like, because root 7 is almost only just 2 steps, right? So because root 9 is itself 3, okay, root 7 is coming to be 2 point something. Okay, so in 2 iteration itself, if I use the sieve of Aristoteles algorithm, okay, I can say that 7 is prime or not. Okay, so but here I need to run 7 iterations. Okay, I need to take 1 2 3 4 5 6 7. Okay, okay, maybe I don't need to do 1 and 7. Maybe I should take 5 steps to do it. Correct, right? I need to check with 2 3 4 5 6. Okay, because we know that one property is like every number is get divisible by 1 and itself. Okay, so if we neglect that, okay, to identify this 7 as prime or not, I need to run this. I need to check with 2 3 4 5 6, which is 5 iterations. Okay, so but with this algorithm we can just identify this 7 as a prime or not by just 2 iterations. Okay, correct. So now we will try to write a brute force approach, that we can use. Okay, to identify whether the given number is what prime or not. Okay, so let's say if I want to say this 7 as prime. Okay, okay, first I need to divide this 7 by, as I told you, I need to divide this 7 by 1 2 3 4 5 6 7. Okay, as I told you, okay, 1 2 3 need to divide by, okay, 6 7. But we know that every number is get divisible by 1 and itself, so that we don't need, it's even if we check with 1 and 7, we get the same result, so we don't need to check. Maybe we need to run a loop from 2 3 2 to 6. Okay, correct, right? Every time we need to take the 7 and we need to divide by 2. Okay, if it is get divisible by, suppose if I take this 7 and if I divide this by 2. Okay, 2 3 is 6, and we get 1 as a reminder. Okay, so when I can say this 7 is completely divisible by 2, only when I have a reminder 0. So but here we have 1. Okay, so instead of doing, what we can do is, so every time we take this 7, okay, we need to run a loop for 2 to 6, 2 to 6. Okay, in general I can say from 2 to, suppose if you wanted to check, if n is equal to 7, okay, you need to check till n minus 1 in general. Okay, I need to take this 7 and I need to divide that by this number. Okay, if I mention this with some variable, suppose I can say that this variable is I is equal to 2 to I is equal to 2. I need to check with 7 percentage I. If it is by chance, if it is equal to 0, okay, if 7 percentage I, okay, by chance if it is equal to 0, so then I can say that this 7 in between this number it is again divisible by some other number, so that this can't be prime. I can say return false. I can write return false. Okay, so this I need to write. So in general I can write something like for, okay, I is equal to 2 to, suppose if I give n as a number to identify whether it is what prime or not, I can need to run this to n minus 1. Okay, and every time I will check if n percentage I is equal to 0. By chance if it is equal to 0, I can say print it is composite, it is composite. Okay, and return return, okay, return false. Suppose a return false. Okay, and even after running this, okay, by chance this statement is not encountered, because, okay, so I can write that it will not be so, because I am coming out of this loop. Okay, so print, I can say if this particular condition executes, but at the time if it is not true, obviously it must be prime. So we'll write a dry run. Suppose if I take, let's say if I take 7. Okay, so now what I will do, we'll just try to run this. Okay, 7. I'll take 7 is equal to n is equal to 7. Okay, so what we'll do first, for I is equal, I currently is 2. Okay, and 7. Okay, so I will run it. I need to run this loop for 2 to 2 to what, n minus 1 means 2 to 6. Okay, so I need to run this loop to 2 to 6. Now the current value of I, okay, the current value of I is 2. Okay, so what I need to do, I need to check if n percentage I, n is what, 7 percentage I is 2, n per 7 percentage 2, 7 percentage 2 means like 7 2 7 3 7 2 3 the 6 1. Okay, 1 is reminder. So this condition, because I'm getting this as 1, so this condition is false, so that I don't need to run. Okay, so again I need to go. It is in this time, what will happen, n become 3, because every time, because we are running a for loop, n becomes 3 now, and we need to check with 3. Okay, 7 percentage 3, when I make 3 this, okay, when I make this as 3, okay, so maybe it will become 3 to the 6, correct, 3 to the 6, and 1 I'll be getting reminder. So I can say that again I'm getting 1 as reminder, so this condition is not true again. So okay, so I need to go back and I need to iterate this 2 again, 4. Okay, fine. So now this will become 4, correct, 7 4. So when I take 4 7, okay, 4 ones are 4, and 3 I'll be getting, I'm getting 3 as what, 3 as reminder. Okay, so see, n percentage high now also, now n percentage I is now also 3. So what will happen? So this condition will not execute. I need to go back, and I just need to increment this n to 5 now. Okay, so 7 percentage 5. Okay, 5 7. Okay, 5 1 is a 5. I'm getting 2 as a reminder, so it will become 2. Again, this is not equal to 2. So what will happen? So this condition will not this condition will not execute, and I need to go back over here. So now I need to run this loop till 6. Okay, this is the last. I become 6, and this becomes 6. Okay, so 7 percentage I will become 1, because 6 ones are 6. Okay, so now again this condition will fail, so it will not work. So now we go back, we stop it. Okay, so this condition finally it's not execute. So 7 is not a composite. What expected result is prime. 7 is prime, because I can say that 7 is not getting divisible by this, so it could be fine. So suppose if I take 4 as this is prime, this is what, if I take 4, what will happen, we'll just check it. Okay, we'll just run dry run this. This is just a brute force approach to identify the given what, okay, to identify. So suppose if I take 2, okay, when n is equal to 4, what I should do, I need to run this loop from 2 to n minus 1, which is 2 to 3. Okay, 2 to 3. Okay, what I have to do, first I need to take n, which is 4. In this condition I am writing n is equal to 4. Okay, so now I should take 4 percentage I is what, 2. So 4 percentage 2, 4 and sorry, 2 and 4, 4 2 2 2 is a 4 0. Okay, 4 percentage 2 is 0. It is, this condition is telling, so print, so obviously print composite. So we are just printing it as composite. So I can say that 4 is a composite number, and after that we will return it. So we will come out of this loop so that it will not do anything. Okay, that is what we wanted to tell. Fine, and we will just write return okay. So something like that. Okay, so this is just a pseudo code to identify whether the given number is prime or not. But in the next lecture we will try to understand this. Okay, so here what suppose here we have to so many iteration to identify. This is just a brute force approach, but in next lecture we will just try to receive of Aristotle's. Okay, Aristotle's is a mathematician. He had given an idea. Okay, to compute or to list the number of prime numbers more efficiently. Okay, that is what we're gonna learn in the next lecture. Great. With this, we are ending this. That's great, and